Okay, is this going to be a hard section or a difficult chapter? Negative. Let's start section 4.2 of negative exponents. Alright, understand the meaning of a negative exponent. Note, the regular exponents still apply. Whoa, back and forth. The same rules of exponents still apply to negative exponents, okay? So, I don't want you to worry about that at all. Let's first understand this. Let's look at something that we touched on last section, but did not actually fully explain. If I have x cubed over x to the fifth, and I use my subtraction rule, this is x to the 3 minus 5, which equals x to the negative 2. Alright? Well, that doesn't really have meaning to us yet, but I think I could write x cubed as x times x times x, and x to the fifth as x times x times x times x times x times x. Okay? And now if I go through and eliminate, or kind of, I guess we could say eliminate, the pairs of x's that we're dividing by, I think I'm going to be left with, these all turn to 1 on top, and I'll be left with 1 over x times x. Alright, which is 1 over x squared. So I think that we could say that an x to the negative power is actually 1 over x to that power. Okay, that's a big idea. That's an idea you want to fully understand. So let's look at some examples of how to deal with these kinds of things. So for instance, if I had, for example, x to the negative 5, we could rewrite that as 1 over x to the fifth. Or if I had x to the negative, actually, let's not even do that. If I had 3 to the negative 2, that would be 1 over 3 squared, and so on. You guys get the idea? And we could go the other way, too. We could go from 1 over y cubed, and that would be the same as y to the negative 3. Ooh, 3. Okay, so that's the idea of negative exponents. Let's do some, a little bit maybe more complex examples here. Alright, I want to touch on something that's really, really important. These are two examples that look really similar, but the parentheses make all the difference in the world. This first one, what I actually have here is a negative quantity, 5 to the negative 3. Okay, over here I've got negative 5, that quantity, raised to the negative 3. Alright, so this one is actually negative 1 over 5 cubed, which is actually negative 1 over 125. Okay, this one, the second one here, is actually 1 over negative 5, that quantity, cubed, which is actually 1 over negative 125. Now, it turns out that these numbers are exactly the same. However, there are certain instances in which that will not be the case. For instance, if this first example here had been to the 4th power, that number would still be negative. This whole number would still be negative, but this one, if this had been to the 4th power, would actually be positive, because negative 5 cubed, that quantity cubed, is a negative number. Another kind of goofy example that arises from negative exponents is when we have something over a negative exponent. And this actually means the same thing as 1 over x squared, which I think we could write as 1 divided by 1 over x squared. And when we're dividing fractions, isn't that the same as multiplying by the reciprocal? So we could say this is actually 1 times x squared over 1, which I think simplifies to x squared. Okay, so this, we start with over here, 1 over x to the negative 2 is actually just x squared. Okay, so that's a rule, and this whole entire process here is something that is a good thing to kind of refresh you on and understand that if I've got 1 over a negative exponent, then it's just that base to the exponent, whatever that exponent is. So if I had 1 over 4 to the negative 1, 1 over 4 to the negative, I guess you can't, 1 over 4 to the negative 1, that's actually going to be 4, a positive 4. Okay. All right. Let's suppose we had something where we're going to combine some of our old exponent rules from the first section with this new negative exponent rule. All right, well, let's see here. The first thing I want to do to simplify this, the instructions are always going to be simplify, pretty much always for these two sections. So let's suppose that I just want to simplify this thing. The first thing that I'm going to start with is this. That's supposed to be a highlighter. Hard to tell, huh? Is this thing on the left here, the 7 to the negative 5th to the 4th. Well, my power of a power rule still apply, so I'm going to go z to the negative 5 times 4, that's negative 20, times z squared. Now, I've got a negative power times the same base to a positive power. That's okay. My rule for adding powers still holds true also, so negative 20 plus 2, and that's going to be z to the negative 18. Now your book is probably going to want you to have it end up in this 1 over form, and then I would tend to agree. It should be 1 over z to the 18. That's the simplified version of that thing. Okay? Oh, this is a good one. Okay, let's apply some of those quotient rules that we learned last section. So even though I've got a negative exponent, rules still apply. So this is just going to change to b to the negative 3 squared divided by b squared. Okay, so we're going to be really careful when we write this. And this is actually going to be b to the negative 6 divided by b to the 4th. And then now I can subtract exponents. So negative 6 minus 4 is b to the negative 10, which we can rewrite as 1 over b to the 10th. Whoa, that 1 is funky. 1 over b to the 10th. Okay, and that's how we would simplify that. Okay, another one. This one, let's simplify. We don't have a power to the power, but we got a bunch of stuff on the numerator, a bunch of stuff on the denominator. So let's look at how we might simplify this. I think the first thing I'm going to do is look at these coefficients here, 16 divided by 8, and that's going to be 8. The next thing I'm going to look at is r cubed over r to the 1 power. 3 minus 1 is 2, so that's going to be r squared. And this next one is, now be careful with the s's, the s to the negative 3 minus 2. So that's going to be s to the negative 5. Okay, and then we should simplify this a little bit more and turn this into, oh my goodness, I'm sorry, mistake, you probably caught this before I did. This is actually 2r squared s to the negative 5th. Okay, and then let's simplify this a little further. 2r squared times, this is 1 over s to the 5th, and that's okay, but I think we could write that a little bit prettier if we wrote it as 2r squared s to the 5th. Now, if you wrote it like this on a test, I probably can't be that picky, because those are equivalent, but this is really what I'm liking here for my final answer. Is an actual just one fraction, numerator and a denominator. Okay, usually I'm pretty big on, completely understanding why things are the way they are in math. This is an exception. If I have a fraction raised to a negative exponent, okay, I can, if you'd like in class, I can show you the expanded reason as to why what I'm about to say is true. My suggestion is just to memorize it. And the rule is this. If I have a fraction to a negative exponent, I can flip the fraction and raise it to that same positive exponent. Okay? So this is actually then would just simplify to 3 squared over 2 squared, which is 9 over 4. Alright, so if I had, for instance, x over y to the negative n, this is actually the same as y over x to the positive n. Oops, that's a 2. Get with it here. Y over x to the positive n. And like I said, the proof to this is not terribly difficult, but it's not terribly important either. So I think it's something that we're just not going to spend time on explaining why. We're just going to use it. let's suppose I had this, x to the 5th over x to the 7th to the negative 4. I'm sorry, shoot, this should be y to the 7th. That's a y. Y to the 7th. To the negative 4. Well, I'm just going to flip it and make it a positive power. That's the first thing I'm going to do. Y to the 7th divided by x to the 5th to the positive 4th. Okay? And now I can use that quotient to a power rule, which says that this is actually y to the 4 times 7, which is 28, divided by x to the 5 times 4, which is 20. X to the 20. Okay? Remember, that's because taking this 4, multiplying it by 7, 4 multiplying it by 5. And that's as simple as I can get it. Okay, now this is a big one. Now, the most important thing about these two sections is that the few simple rules that you know are very, very powerful and can make complicated things a lot more simple. All right, or a lot simpler. I'm not an English teacher. Let's flip. The first thing I'm going to do is flip this fraction, because I've got to the negative 5th. I'm going to change it to the positive 5th and flip it. So this is z to the 4th divided by x squared y to the negative 3. Okay, that's the first thing I'm going to do. Now, I'm going to do a little analysis here. This y to the negative 3rd, I'm going to deal with that in a second. You know what? I'm just going to say this is actually on top going to be z to the 20th, right? Power to a power, divided by, on the bottom, I'm going to have x to the, okay, careful, bear with me here, 5 times 2, oh, we need a different color. Let's do this. 5 times 2, and then 5 times negative 3. Okay, so this is x to the 10 and y to the negative 15. 5 times negative 3. Okay, now that y to the negative 15, I got to simplify that. So this is the same as z to the 20th, leave the numerator alone, divided by x to the 10th. And this is going to be times 1 over y to the negative 15th. Oh, remember, we said whenever we have 1 over y to the negative power, that's the same as z to the 20th divided by x to the 10 times y to the 15. Okay? And then, one more step further, and then we'll call it good. But this is z to the 20th times y to the 15 divided by x to the, oh no, I ran out of room, divided by x to the 10th. Z to the 20th, y to the 15 divided by x to the 10th. Okay, and that's my final answer there. And that's it.